In this lesson, we're going to be talking about this concept called a literal equation. And a literal equation, you can identify it by just looking at it. It's an equation that has a lot of variables in it. And what you're going to be doing is you're going to be solving for one of the variables. And this is a really applicable concept when it comes to upper level maths and upper level sciences such as chemistry or physics, because you're going to be working with different formulas and different equations, and you're going to be looking for specific variables within that formula, and you're going to be solving for them. So this concept is really going to be following you throughout your school career. So let's go ahead and talk about this literal equation. Let's look at the first example. So you see my first example, it's asking me to solve for x. So my equation is y equals 5x minus 6. I do have two variables in there, x and y. So it might feel kind of weird to solve for another variable. Right now, the equation is solved for y. I have y all by itself on one side and then all the other stuff on the other side. What I want to do is reverse it, and I want to get x all by itself on one side of the equal sign. So here's how you do that. I'm just going to kind of work my way into the x. So what I'm going to do is, just like solving an equation in a way, I'm going to try to get that x isolated. So I'm going to start by, just like I would solve a two-step equation, I'm going to eliminate the negative 6. I'm going to eliminate it by adding it to both sides. So if I add 6 to both sides, that's going to look like this. Now, I know this is going to feel weird, but I'm going to write y plus 6 over on the left here. And that's going to equal 5x. And my 6's are going to eliminate. I know that feels a little weird, but don't worry, we'll get used to it. Now we're going to get the x by itself. And 5 and x are being multiplied together, so I'm going to divide both sides by that 5 to eliminate it. If I divide this side by 5, I also need to divide this side by 5. That's the rule of equations. So in doing so, what that's going to leave me with is y plus 6 divided by 5 is equal to x. And I've done it. I like to put the variable that I'm solving for on the left-hand side. So I'm just going to go ahead and flip him around. X is equal to y plus 6 divided by 5. And I'm done. I've solved my literal equation. Okay. Let's go ahead and just try some more. I've got a lot of examples here because the more examples we practice, I think the more this will become second nature to you. Okay, let's go ahead and solve for the variable h. Now, if I wanted to, I could solve for the variable r if I wanted to, but I'm not doing that right now. I'm just solving for h. R is a little bit more complex. So let's go ahead and solve for h. You can see that right now it's set equal to v. So I'm trying to eliminate pi r squared. You can also see that all three of those terms on the right-hand side are being multiplied by one another. So what I can do is I can divide both sides by multiple terms. I'm going to multiply it by pi r squared. If you want to take it one by one and divide it by pi and then divide it by r, you can do that. But this is a nice, easy way to do this. I'm going to divide the right by pi r squared, and I'm going to divide the left by pi r squared. Watch what happens. Over on the right-hand side, my pi's cancel out, and my r squares cancel it out, leaving me with that h. So I have v over pi r squared is equal to h. And I'm just going to go ahead and flip it around. H is equal to v over pi r squared. So if I was working a chemistry problem or a physics problem or anything like that, and I wanted to solve for that h, this is how I would do it. And that's my final answer. Okay, let's look at another one. Let's solve for b in this example. So right now it's set equal to a, and I want to find the b. So I got to kind of work my way in. So just like working with regular one and two step equations, I need to work from the outside in. So I'm going to first start by eliminating that h. It's being multiplied by the quantity b plus c. So I'm going to go ahead and start by dividing both sides by h. By doing that, that's going to leave me with a over h is equal to, my h's are going to cancel out, and I'm left with b plus c. And I've dropped the parentheses because I don't really need them anymore. All right, I want to solve for b, so the last thing to do is I'm going to subtract c. Subtract c from both sides. I'm going to bring my work right up here. Sorry about that. So now I'm going to have a over h minus c is equal to b. And I've done it. I'm just going to go ahead and flip it around. B is equal to a over h minus c. Now, if I could just add a little comment here. Notice how the variable a is capitalized. Make sure if you're given a capitalized variable that you keep it capitalized. And if you're given a lowercase, you keep it as lowercase because you can't change the variables within the problem. Okay, let's try another one. This one we want to solve for y. So let's go ahead and work our way up to the y. Now, if this was a regular two-step equation with numbers, I wouldn't start by subtracting x from both sides. You know that. We would start by eliminating that denominator. So I'm going to do that here. I'm going to multiply both sides by 2. That's going to leave me with 2a equals x plus y. And it leaves me with x plus y because those 2's eliminate. And I think we did that back in the section in Unit 1. Okay, now let's go ahead and solve for y. One more step. Let's subtract x from both sides. That's going to leave me with 2a minus x. Since I'm working with variables, I can start working horizontally versus vertically. That's going to equal y. And of course, I'm just going to go ahead and flip him over to y is equal to 2a minus x. And that is my final answer. Now, again, if I wanted to solve for x, I can absolutely do that. I just happen to be looking for y in this case, but we can always be solving for different variables in these types of problems. Okay. I have some more problems for you. I bumped up the rigor just a little bit, just for extra practice. And feel free, if you're starting to get the hang of it, feel free to pause the video and try these on your own before I show you the solutions. For this example, I'm going to show you how to solve for y. And let's go ahead and let's work with getting rid of the x first, right? I'm going to go ahead and eliminate that 12x. I'm going to move him over. What I mean by move over is I'm going to balance that equation to eliminate him on the left-hand side. Okay, now let's simply just go ahead and get rid of the negative 4. He's being multiplied by the y, so I'm going to go ahead and eliminate him by dividing both sides by negative 4. Over on the left, it eliminates him to give me that y all by itself. But look at this. Isn't this unique? This is from Unit 1. Do you remember this concept where I have this little butterfly thing where I take 20 divided by negative 4 to give me negative 5? And then I have that same idea here with the butterfly. Negative 12 divided by negative 4 is going to be positive 3. So leave me with positive 3x. Do you remember that? What I mean by butterfly, these little antennas here. Yeah, well, that concept is going to apply in this case. So we solve for y, and we're all done. Again, if you wanted to solve for x in this case, you could, but the problem was specifically asking for y. All right, let's solve for z in this next one. I have to get to the z, so to get there, I need to eliminate that denominator. So I'm going to start by multiplying the right-hand side by 6 and the left side by 6. Whatever you do to one side of an equation, you have to do to the other. That's going to leave me with 6x, and that's going to be equal to yz after my 6's are eliminated. Then I'm going to go ahead and I'm going to eliminate the y by dividing both sides since they're originally being multiplied. My y's are going to cancel out. And I'll be left with 6x divided by y is equal to z. And like I love to do, I'm going to go ahead and move that variable, flip him around. And there we have it. We have solved for the variable that it asked for. All right, couple more to practice here. Let's go ahead and solve for a in this one. I'm going to go ahead and get rid of that denominator. Am I emphasizing that elimination of the denominator enough here? I hope so. So that's going to leave me with 4x is equal to, my 4's are going to eliminate. I'll be left with 2y minus a. And to get that a, here we go. I'm going to go ahead and subtract 2y from both sides. Now this is where it gets a little tricky, so be careful here. That's going to leave me with 4x minus 2y is equal to, I'm eliminating the 2's, but notice what I still have. I still have a negative a. You can't forget about that negative because it's not complete at this point. I have to eliminate the negative. Right now, it's a negative 1, Harold, being multiplied by a. So I'm going to divide both sides by negative 1. And look what that did. My negative 1's are going to eliminate over here, leaving me with a on my right-hand side. But do you see what's happening on the left? It's the butterfly thing again. 4x divided by negative 1 is going to be negative 4x. And then negative 2y divided by negative 1 is going to leave me with positive 2y. There's the little butterfly. So if I flip it around, a is equal to negative 4x plus 2y. I know that was a little bit more complex because what it was doing was it was including all of these skills that we've been learning and putting them into one problem. This is where algebra starts to get a little challenging. All right. Last one here on this page says solve for x. All right. Notice how I have a fraction. Again, get rid of that denominator. So these are all being multiplied. So I'm just going to multiply it by 2. That's all. So that leaves me with 2y is equal to, my 2's are going to cancel out, and whatever I have left, I'm going to keep. So I have 1xbl. And to solve for my x, I'm going to divide both sides of the equation by BL. That's going to leave me with 2y over BL equals x. And there you have it. So x is equal to 2y over BL. And I'm done. All right. Feel free to stop the video at this point if you're getting the hang of it, or continue on. I do have some very unique problems here. And this is a unique situation that sometimes happens that can kind of get confusing. So let's talk about it. It says, what happens when you have two of the same variables in an equation? You notice all the other problems that we've done, they've all had, a lot of variables, but none of them were the same. So let's look at this first one. I want to solve for r, but notice that the variable that I'm solving for, there are two of them. There's this very unique thing that I need to do to make one of them. And the word that I'm going to use right now is undistribute. The real terminology for it is factor, but we're going to be learning about factoring way down in Unit 9. So I don't want to get there too quickly, so I'm going to use the word undistribute. I'm going to undistribute in R. Let me show you what I mean. I'm going to set S equal to, I'm going to undistribute the common variable. It's also the one that I'm solving for. So I'm going to put him here like this. Then I'm going to put some parentheses. Now, if I were to distribute R into the original R, I would get a 1. If I were to distribute R into negative GR, that would leave me with negative G. What I mean by that is, go ahead and try to distribute that R now. R times 1, doesn't that give you the R? And then R times negative G, doesn't that give you the negative GR? I undistributed it, or factored it, to get me R by itself, or just 1R. Now at this point, I can go ahead and solve for the 1R. I'm going to do that by dividing both sides by that quantity 1 minus g. So I'm going to go ahead and divide the whole thing because it's a big chunk, and it will eliminate it all together. So 1 minus g is eliminated. And I'm left with S over 1 minus g is equal to R. And I'm done. But I am going to go ahead and rewrite it as R equals S over 1 minus g. And I'm done. That's how you undistribute. Let's try another one. This one's a little harder because now I have variables that the variable that I'm looking for, x, is not only on the left, but it's also on the right. So the first thing I need to do is I need to put them together so that I can do that undistribute thing. So let's go ahead and get everything that has an x on one side and everything else on the other side. Let's go ahead and take a second to do that. All right, I'm going to go ahead and I'm going to move x, y over to the other side. So I'm just going to go ahead and add him to this side. That's going to leave me with 7x plus xy minus 2z. Notice how I brought him down. That's going to equal 4. All right, like I said, I want to get everything with the x on the left and everything else on the right. So let's go ahead and move him to the other side here. So I'm going to move 2z. He doesn't have an x in him, so I'm going to go ahead and move him to the other side. All righty, here we go. 7x plus xy. I'm going to eliminate these guys, and I'm just going to rewrite them over here. All right. Now I have those x's on the same side. So let's do that undistribute thing. I'm going to undistribute an x. And if I undistribute, what am I left with? I'm left with a 7 and I'm left with a y. I can always check myself by redistributing my x into my 7 and into my y. That's going to leave me with 4 plus 2z. Now, let's go ahead and solve for x. I'm going to go ahead and divide both sides by that quantity, just like that last example that we did. A quantity you can always just kind of put together as a chunk. So 7 plus y and 7 plus y are going to eliminate. And I'm left with x equals 4 plus 2z over the quantity 7 plus y. And I am done. Alrighty. So that is kind of a more complex type of problem, but now I'm going to show you 2 examples that are real application examples. These are real formulas. One is actually a chemistry formula, the first one, and the other one is actually a formula we're going to learn in Unit 4. This is called point slope form. So let's go ahead and try these. These are kind of fun. All right, for this one, we want to solve for t sub 1. Now, these little numbers, the 1s and the 2s, that just means that, actually, let me explain the formula. The formula, the P is going to stand for pressure, the V is going to stand for volume, and the T is going to be temperature. So you're comparing 2 different, let's say containers, and their pressure inside the container, the volume, and the temperature. And the 1 represents the first container, and then the 2 represents the second container. So you're looking at 2 different situations with different pressures, volumes, and temperatures. And we just want to figure out, well, let's solve for the temperature of the first one. That's all we're asked for. So let's go ahead and do that. Now, notice how T1 is in my denominator. I don't want that in my denominator. Let's go ahead and put him in the numerator. All right, so what I'm going to do is... Actually, can I step back a second? This looks really familiar, doesn't it? Doesn't this look like a proportion? It is. Couldn't we use our skills that we've done with cross products to figure this one out? Let's go ahead and use the cross products. That's a cool little nifty tool that we've already learned about. So I'm going to set it up as T1 times P2 V2, right? I don't need to show any parentheses because they're all being multiplied. And then T2 and P1 V1. I just set them equal to each other. And I want to solve for T1. So let's divide both sides by, you got it, P2 V2. Sounds like R2D2, doesn't it? All right. Over here, my P2 and my P2 and my V2 and my V2 cancel out, leaving me with T1. On the right side, nothing cancels out. So I'm just left with T2, P1, V1 over P2, V2. And there it is. I solved for T1. Kind of a complex problem, but using the skills we already know is really helpful. All right, and the last one here, this is going to be a formula that we use in Unit 4. And we want to solve for x. So let's go ahead and work our way into the formula. Of course, I have my m here that I want to eliminate first. He's being multiplied, so I'm going to start by dividing both sides by m. And that's going to leave me with y minus y1 over m is equal to x minus x1. and I want to solve for x. Just be very careful. X and x sub 1 are two different numbers, and I want to solve for x. So I'm going to go ahead and I'm going to add x sub 1 to both sides. All right, so here we go. I've got y minus y1 over m, and I'm going to add x1 to that, and that's going to equal x. So my final answer, x is equal to y minus y1 over m plus x sub 1. There it is. All right, so that brings us to the end of our lesson on literal equations, and feel free to take some time to go ahead and review some of those problems at your leisure.